help you guys in your jobs. We'll be presenting ESG research. Research we poll thousands of end users like yourselves about emerging trends and technologies, some of the challenges around storage virtualization, storage performance. Also be looking at some of the emerging technologies that are becoming available to help solve some of these problems. Some tools and tricks that are available, best practices. I've links to a bunch of best practices for tuning certain application workloads in virtualized environments. We're talking a little bit about this emerging and new challenge of when you mix applications together in a virtualized environment. How do you deal with that? How can we learn more about that? We've done a bunch of testing of that. So we have links to reports there as well. So I'll put this up at the end of the presentation as well. There's a QR code here. If you've got a smartphone and take a picture of that, this will get you access to a microsite that has all the slides here, so you don't have to take any notes. Also give you access to all the ESG content that we have, our demand-side research, all the reports that we're talking about. It's worth about $600, and you'll have free access to that for 6 months to give it a try, so it can help you guys out. I'll put this up at the end again, so plenty of time. Picture now. And again, we've got really, really hot room. I'm standing between you and lunch. There's a ton of information to cover here. I'm going to try to skim across a lot of this. Feel free at any point to ask any questions. The goal is not to try to cover all this here, it's to give you something that you can use to try to help understand this emerging complex issue. So, with the Enterprise Strategy Group, we're the industry analyst firm, anchored in world-class research and hands-on testing and validation. The hands-on testing and validation is the stuff that I do. I used to make the stuff that I now test and write about, so I'm a patent holding engineer. I've done about 350 of these projects where we go typically to the vendor, we're making the solution and work with them together to try to figure out how can we prove that what they say the solution does it really do it. Pertinent to this, we've done a lot of work in virtualized environments, both with VMware, Microsoft, Citrix, and all the storage vendors wrapped around it to address this problem of storage performance in virtualized environments. We've done probably a couple dozen reports in that area. So I'm touching on some of the things that we've learned there. We'll start quick with just some ESG research. It's probably not a surprise to you. How many in your organization would consider server virtualization to be a top IT priority, the top 3? Excellent. So our research has shown that it's been up at the top of the list for the past 3 or 4 years. Continues there, and increasingly we're seeing, early adoption was VMware. But we're increasingly seeing mixed hypervisor environments, maybe a touch of Microsoft Hyper-V or Citrix Server. Are any of you running multiple hypervisors today? One, couple? A little bit more of that. And when we asked about how to gauge virtualization success, a variety of metrics, savings is obviously one of the first drivers to get there. When we get down the list, application uptime and performance shows up early on the list. So being able to guarantee and get the performance after you virtualized applications that you were able to do before virtualization is a key criteria of whether it worked or not. We're finding that performance and scalability challenge can be a barrier to getting all of your application workloads virtualized. What I have here is a picture of kind of the, over time, you can look at this for the industry or a particular organization, your journey to virtualizing particular server virtualization. Typically, you would start with low-hanging fruit, the easy utilities, IT-owned applications, your print servers, Active Directory, things like that. They're quick and easy because they lived on those servers before. We can get quick and easy capital equipment savings. Ideally, we'd move on to the next stage and start virtualizing bigger, more mission-critical applications and taking better advantage of not just the capital savings, but starting to take advantage of high availability and mobility. The ability to respond a little quicker to the needs of the business, and ideally to start driving operational savings. To get to that last stage, that means the most mission and business critical applications, you have to trust that they're going to work in a virtualized environment. We found that there's stalls within organizations and in the industry along this curve. Is there anybody here who's 100% virtualized? All of our applications are virtualized or VMware? I'll go there. How about 50% or less is where you're at right now with your applications. So that's the represents roughly what we've seen. There's a couple percent, 10-15% who are virtualizing 100%. There's a variety of reasons. This performance and stability is just one. There's lots of other reasons, basically whether your application is even supported yet, whether the platform it's running on makes sense. There's some old applications along hardware that might not be virtualized yet. So when we look at these stalls along the way, what we've identified and through survey research is that application performance and scalability are key concerns. And this often comes down to storage. So why do we even bother bringing everything together in a virtualized environment from the virtualized storage environment? And just like in the server environment, the more servers that I can consolidate together, the more I can save money on buying less servers, less power and cooling, so I get the same benefits, one common pool. So it's just one place that I can manage that from. So theoretically, it makes things easier to manage and implement as well. And along the way, we can now start taking better advantage of VM mobility and advanced HA and disaster recoverability, things like site recovery management, powerful technology from VMware to replicate applications between sites to make that a little easier to do working with storage systems. Along with those great opportunities come challenges. So what are the challenges in the storage in a virtualized environment? It really comes down to guaranteeing the performance that you need for your business, particularly for these business critical applications, things like Exchange, or maybe important SQL Server, SharePoint infrastructure, or a web server. And what are the challenges as we take virtualized application workloads and start mixing them together? Before, we were running them on a silo where I knew this server was sized perfectly for the storage for this application. It was easy to provide predictable performance. To start mixing the applications together, the impact from one application that may be lower priority can have on the mission critical application is something we need to learn to deal with. A simple thing like the backup jobs running is something we were used to before. It's kind of a small microcosm of this. The backup job runs while email users are running. If that happens during the day, you need to do a big restore, or somebody's trying to get email done while the backup's going on at night, they're going to feel a slowness in performance. Having more eggs in one basket. So as we bring a consolidated pool of applications into one infrastructure from a server and storage standpoint, now availability and high availability and recoverability matters more. Ideally, you have a better place to do it from, but it matters more. You've got, in essence, more eggs in one basket. We had the I/O virtualization blender. I touched on this a moment ago. I've been doing storage performance characterization and tuning for most of my career. And understanding an application in isolation and the way that it behaves and getting the storage system to give you the best performance and the best bang for the buck is it's a relatively hard thing to do, but we've got tribal knowledge that we've gained over the years. And we really we know how email applications behave. For example, Exchange is it's mostly random reads, a little bit of sequential writes for the logs, and it's about that being cat. Okay? And then we take something totally different, like a backup job. For reading data to do a backup read, that's large sequential reads, or from writing data down, it's large sequential writes. The databases, depends on the kind of database work you're doing. If it's online transaction processing, tends to be in the Microsoft world, the SQL Server 8K, mostly random reads. Looks a lot of but if you're doing long-running reports, the application workload changes. Now the challenge is if you mix these all together and you're sharing the same storage infrastructure, you get this I/O blender effect. And everything that we've learned goes out the window. Everything can get randomized. And in the worst case, it can actually flip things totally upside down. Desktop virtualization is actually that case where it really flips things totally upside down. Doing or virtual desktop infrastructure, the best way to do that is to work off of a Win clone where everybody's working off of one master gold image. I can maintain this image of, say, Windows 7 desktop that everybody's going to be using. Ideally, I can keep this one master image there, and I use technologies generally for these link clones that everybody's using the virtual copy of that. All I have to do is store the unique changes for each user. My preferences are a little different than the guy next to me. But we're storing one gold image, and the great advantage now is, from an IT standpoint, I can just maintain one image, keep it all up to date, it's easier to distribute. The challenge that this proposes is the I/O virtualization blender effect happens where it takes the workloads that happen at our desktops are mostly random reads, occasionally write stuff. Every desktop user does maybe 10 to 20 IOs per second. It's relatively low. You get hundreds and thousands of users going together, and the Blender flips it upside down, and it ends up being mostly random writes, 8% random writes, and 20% random reads. What happens is we're storing just the changes for all the users. The part that we all rely on, ideally, is being serviced out of some cache at a higher level above us. So it's a real challenge, a real problem. And it's also an opportunity for the industry. We've got all these great new tools to help solve the problem and solve this. So if we look at, on the top left, we have a virtual server. We're going to a storage system in the middle, and we optionally remote replicate to another site. This whole path, anywhere along here, there can be data bottlenecks that can get in the way of delivering application performance that we need. The applications themselves can have performance problems. The hypervisor layer, the server itself, the path of the storage through the storage network, storage system, and the WAN on the other side. I highlighted disk drives and WAN. These are typically the places that would show up the most. Having the right number of disk drives or the right type of disk drives for a group of shared applications is a really hard problem to solve. You need to be able to understand the performance needs and make sure you've got either enough traditional disk drive actuators or traditional disk drives and a mix of solid state, called a hybrid, or in some cases all solid state. And then if you're remote replicating, just the size of the WAN bandwidth is another really big potential bottleneck along the way. So the storage technologies are being used to solve these problems, solve these storage performance problems. So SAN and unified, so block-based, fiber channel or iSCSI attached SAN storage systems, either modular or enterprise class level. It's typically when enterprise class organizations are deploying virtualized storage. You really need shared storage to get the best bang for the buck and get the best benefits out of a virtualized environment. If you want to do a VM, VM mobility between virtual machines, you need them to be connected to the same storage, so when you get to the other side, you can see it. There's some emerging technologies that are just beginning to make that available with direct attached storage, but in general, most people are using shared network attached storage. And increasingly using it with unified both block and file, NAS and SAN. Sometimes you buy them together in the same system, modular systems that can do that. That's another popular way of doing this. Automated tiering technology, we'll talk about this, and sub-level tiering technology is a relatively recent innovation. It's helping improve performance and solve some of these performance bottlenecks. Scale-out storage is another really phenomenal new technology that's coming along to make it easier. It's not a panacea. We'll talk about some of the trade-offs for it, but it's another great technology. You can hear an awful lot about solid state. We generically refer to all the solid-state storage systems technologies we use here with this solid-state storage acronym, SSS, ESG. There's a variety of ways that you can deploy solid-state in your environment. The first thing we saw was drives or solid-state drives where it's in the same form factor as a drive. You plug it into your disk array, and instead of plugging in a mechanically spinning drive, plugging in something that looks and feels the same on the outside, but has no moving parts inside, so it's a whole lot less power. It's 10, hundreds, sometimes thousands of times faster. It's also a lot more expensive. This can be deployed on the server end of the wire, storage end of the wire, sometimes even an appliance in the middle. In early implementations, you kind of sharpen pointing and expensive tools. You had to figure out exactly where you use this expensive resource. Place one of these solid-state drives, for example, if you knew that this database volume, these indexes could benefit from really fast performance and allow you to do more transactions per second, for example, deploy it as a drive. Increasingly, we're seeing it as a tier or a cache as well. And as I mentioned before, you can buy systems that are all solid-state or a mix of solid-state and drives. I'm actually a real fan of the hybrid, cost-effective approach. And another topic I'll touch on briefly is quality of service. It's just a relatively recent storage innovations coming down and becoming available for this. So talk a little bit, the unified storage systems like block and file are good for virtualized environments. The ESG, the way our little company uses VMware technology right now is actually a good example of a mix of block and file. So we've got 2 servers virtualized with VMware vSphere, and we use block high-SCSI storage for our Exchange and SQL Server. The SQL Server is still behind our SharePoint. And then we use file interfaces like NFS or BMDK images, those are operating system images, and to export shares, home directories and corporate share drive. We can do that all in one storage system, so that's a unified with Ethernet in the front can offer up all those services. And in general, there's entry to enterprise class versions of both these block versions and in some cases the unified that can solve these needs for very small, medium-sized to extremely large organizations. So what matters the most for your virtualized environment, and if you're bringing an application into an existing virtualized environment or considering physical applications that live in physical servers and moving them to a virtual server environment, the thing that matters the most is being able to handle the peak I/O requirements of the mix of the applications. What you need to do is try to understand the performance characteristics of your existing applications. We're a real fan of you really can't improve what you can't measure. And so one of the things we need to do to understand and move to a virtualized environment with storage is what are my existing performance requirements for my applications. And there are a variety of tools you can use in the operating system level, in the Microsoft world, there's IOStat, VMstat, Unix, and Linux worlds, just to give you a basic idea of here's my IOPS requirements during for these particular applications. You can get response time level and get a little bit of information into the end user application response time level as well through other tools. That'll give you a good baseline. Go this way. Subvolunteering, we mentioned this briefly. This technology is now we can take a portion of a drive, or a LUN is a logical addressable unit of storage, and we can take chunks within that drive and have that move up or down in tiers of storage. And we want to move it up to get faster performance and down to get better cost. And so this came about 5-6 years ago, first with just fast drives, say 15K RPM drives, and really dense SATA drives, for example, spin slower and a lot more affordable. Drives going to be a couple hundred gigabytes, say 600 gigabytes of fast drives, and a couple terabytes more cost-effective drives. And the idea is that based on the application requirements, the system automatically moves stuff up when it needs to go faster and moves stuff down when it goes slower. This technology was relatively new and not mature and well used 3, 4, 5 years ago, and all the major systems vendors have it, and it's becoming a really good and powerful tool that generally just works behind the scenes for you and gives you a better bang for the buck.
And it's not just drive times, it's RAID levels.
Exactly, between RAID levels, and now we can put solid state as one of these tiers as well. Yep, exactly. We can go between mirrored or RAID 5, and mirrored can give you better performance in some cases, RAID 10, RAID types. Drive types, solid state and traditional drives. So in the implementations in the algorithm, the solutions that are out there for these, for subLUN tiering, there are slight differences between them. There's a lot of marketing FUD and craziness around my chunk size or the amount that I tier up and down is better than yours. The frequency of updates is better than yours. There's some truth to that, depending on your application workloads, but in general, the whole market is starting to figure out what's the right level of how quickly to react. If you react too quickly, you're churning and moving things up and down. If you go too slow, you might not be able to respond quick enough to peak in performance. But in general, these problems are being fixed across the industry. So I want to make this point pretty clearly that there's a lot of hype right now around solid state, and particularly in virtualized environments. You see vendors, especially emerging vendors now, coming with solutions that are all solid state. And great potential technology, but right now the cost for those is still dramatically more expensive than a traditional disk. Using things like deduplication to try to bring the cost down. And it's showing great promise, but in general, they're providing more performance than you generally need from those virtualized environments. Typically, your applications, you only need maybe 1 to 5% of their capacity is the hot spot. They could benefit from solid state. So if you could use the subload tiering technology with just the right mix of solid state, it can really help solve things. Just chatting down on the floor with just started up called Cloud Physics that provides a freely downloadable virtual appliance that you can install. It will monitor and capture statistics to help you figure out how big is that hotspot and which applications could benefit from the most and provide service. I think they're up here this afternoon. 321 and 1 and 3. I think they'll be chatting. Scale-out storage. So traditional modular storage controllers were usually dual storage controllers for high availability. In case one broke, the other one would go. And it was active and passive or active-active flavors of this. And that was how the modular world worked forever. And in the enterprise class, there are usually more than 2 controllers. Lots of them, highly available to solve the needs of your business. What's happened lately is something in between where we can scale out using typically the traditional server-based technologies, sometimes used up with a little bit of hardware. And I can continue to add these controllers so I can go beyond 2, 3, 4, 5, 6. Equal Logic, that bought by Dell, that 10 that got bought by HP are examples of this technology. And the idea is that as you can grow to meet the needs of your business, and they can kind of take advantage of all these new controllers that you're adding and drives that you're adding to meet the performance demands and automatically tune the needs of the business. They can also provide one single point to manage it from. It's worked out really well. But there are some potential caveats that can you isolate for high priority workloads. So if everything is working together in a virtualized, one virtualized pool you're scaling out, the challenge is as you scale up, basically every application is getting as fast or as slow at the same time. And as big mixed workload, you may need some of the controls you're used to in a more traditional environment, right? And dedicate some of the resources to a particular application and guarantee performance. That's something you need to look for and ask for considering scale out. Do I still have the tools that I can set some level of priority? Solid state storage. I talked about a couple different variations of this. PCI cards with solid state in them, you can stick in the server end of the wire. Sometimes they're stuck in the storage controllers as well. When they're in the server end of the wire, they're the closest to the application and the CPU, so that's the fastest, the lowest latency. In the virtual server environment, though, it's generally a problem that it's not highly available and shared. So this problem is beginning to be solved. This is generally being used for applications that are providing clustering at a higher level. Talk about all SSD solutions. Deduplication is deduplication technology first came about for backup data. Lots of duplicates of backup data, the same stuff over and over. So we've got ESG lab validations of dozens of deduplication solutions over the years, and the idea is to back up the disk, get rid of the duplicate data so that I can do it on disk cost effectively and provide cost that's kind of close to take. So enable people to switch over to a backup to disk strategy and shrink their backup layers. The same technology is being used for primary storage. You use deduplication to reduce the cost of this expensive flash and get it down to be about the price of traditional disk technology. So this is mostly happening from startups right now. There's some really great new technologies coming along. Deduplication does help with that cost equation, but it does add some overhead. Just like in the backup to disk world, there's a couple different ways of doing it. You can do it as the data comes in, called the inline, or after the data has arrived, which is called post-processing. There's a variety of trade-offs along there from a performance standpoint that you can consider. Legacy architectures, both modular and enterprise class from all the major vendors now, generally you can stick solid state in them somewhere. But in general, you can't fill them all up with solid state yet because the plumbing isn't equipped for these speeds. Their internal bandwidth, the processing power is evolving over time to take advantage of it. That's what's given the room for these startups to kind of start from scratch and say, hey, I've got this new medium that's going to go much, much faster. Let me have a system for it. I touched on Riley's talking about, I didn't talk much about flash as a cache. About flash, using that as a tier. But just like storage controllers have been using RAM as a cache inside of them to make the storage controller go faster. Even our disk drives have a little chunk of RAM in them as well to speed things up. And there's cache in the server as well. We've got the two cache right next to the processor. So cache everywhere in the compute chain generally helps and makes things go faster. And the right mix of cache, if you do it cost effectively, can help you get much better performance. Flash, I think, implemented as a cache is a really great new evolution. We're seeing the major vendors starting to provide this, flash as a cache, or as a tier. Startup solutions are doing the same thing. This is a great way to take just a little bit of flash with more traditional disk and give you the performance boost for a little bit of data speed boost frequently. Quality of service, I just want to touch on this really briefly. Probably you know this from the networking world, quality of service, particularly with a very expensive wide area network circuit, or internally within your LAN. You want to be able to set a defined level of service for certain applications. For example, for your VoIP, voice over IP, you need a certain level of bandwidth so the calls don't drop, and you need a certain level of performance for your mission critical applications. So that concept's pretty well known in the network industry. Not so well known here in the storage industry yet, but the same thing applies. Deploying storage infrastructure, we want to set it out and say, this application is more important. I want it to go get the most resources to go as fast as it can. Or I want to dedicate some of the resources in the system to this mission critical application. And this one down here, maybe my backup job, for example, I don't want it to get in the way, so I'm going to have a low. This concept's actually been around in the enterprise class storage. VMAX, HCS, ESP, IBM DS8000. They have these tools that have had them for 10, 15 years, but they generally, you need to know a lot about the storage system, and using a simple dial per application, really you kind of have to know you're managing groups of ones, usually managing resources instead of a dial to say this is more important. You're usually saying, I'm going to dedicate a chunk of the shared resource, a chunk of memory, these host interfaces to that application. What we're seeing is just starting to happen some innovative, easy ways to do this in the storage world for virtualized environments. Just tested one, the guys who founded Left Hand Networks and sold it to HP, have another company called Next Gen Storage. Next Gen Storage is a hybrid solid-state solution with PCI on flash card and then some real-time SAS drive behind it. It's optimized very well for virtual server environments, including this capability to find mission critical, business critical, basically 3 levels of priorities. These are my important applications from a performance standpoint. I want to guarantee a certain level. This is the second most important because I don't care that much about. So we ran some tests where we simulated a long database query job running and a backup job, and showed that we can guarantee level performance and that it could ride through that. And more importantly, through anomalies and things that can happen. This is what really matters during RAID rebuild or a controller failure. And this has been a historical problem in the industry and something that we don't pay enough attention to. If you want to guarantee a level of performance for your application, you need to make sure that you can keep that while something goes wrong. If you lose a controller and you're in a single controller mode, or you lose a drive and you're doing a RAID rebuild, it can really wreak havoc on your storage performance. Yeah. So in this case, we started a RAID rebuild, and we can see that the low priority applications actually dropped dramatically, while the applications that matter for us stay up. A little bit about performance benchmark testing. Traditional benchmark testing, we're usually benchmarking one application, a server attached to some storage, and we're looking at one application. in virtualized environments, then we need to understand what happens when we run a mix of applications together on an infrastructure. For example, an email, a web server, a database server, and I got a backup job running. It's a very typical thing that can happen. And so it's taking a little while for standards to evolve and for the benchmarking resources that are available to switch and change for this. VMware was actually kind of a leader with something called VM marking here. And it's since become an open standard called SpecVer. And what they do is they call this a tile concept. They'll take a tile and a group of mixed workloads together, we'll run them, and we'll continue scaling the number of tiles until the level, until the performance starts to fall off, and you give it a score. Server vendors have really latched onto this. It's a great way to show which server is best for virtualized mix of application workloads. It tends to stress the server. And typically, when vendors test this, they usually put plenty of storage behind it or put solid state to make sure that that's not the bottleneck. So the thing that they're focusing on is the server. We have this problem, similar problem. We want to do the same thing for storage. We want to focus on storage. So ESG Lab, we published a bunch of reports where we use a similar methodology, but instead we're using 2 or more physical servers and enough physical server, and on purpose waiting running until we hit the storage bottleneck in the virtual server. So results from methodology like that, where basically has 1 tile or 4 VMs, moving up here to 4 tiles or 16 VMs running in parallel. What we're looking for here is kind of predictable performance scalability. That as I scale up the number of machines, that in this case the number of IOs per second for each application is scaling roughly in a linear fashion. This is with there's actually a very big difference in storage architectures as to whether they can do this well. If you have a scale-out storage system where it's trying to do everything automatically, it might not give you this predictable performance. It might start to flatten out. In general, traditional technologies where you can kind of dedicate resources and RAID groups to these works really well for this. You can kind of predict if I want to dedicate a host interface and a set of drives to an Exchange application, I've got a chance of guaranteeing performance for it. Tools that we use for this. There's an industry standard tool called Ionomer. It's a downloadable, freely downloadable open source. I've got a link to it at the back of this. It's easy to emulate application workloads. It's also easy just to get storage performance numbers and number of IOPS that the system can get. The application workloads that we use for this test and a variety of others, we use that tool to emulate real workloads. We've captured that in an Ionomer configuration file that's freely available with some documentation that's available through this. The link that I gave you there and sitting behind a microserver. So in that case, we tested up to 20,000 Exchange from mailboxes. So I'm just going to briefly flip through these. It's really hot. I'm standing between you and lunch. We've done a variety of virtualized application tests with workloads with the goal of showing predictable performance scalability for, in this case, 5,000 to 20,000 Exchange users on. This was showing that the I/O virtualization stack, we wanted to make sure that that wasn't a bottleneck. Predictable database read response time for Exchange. That, you see I painted it red, 20 and 25. This is the milliseconds over here for the database response time. That's actually the Exchange guidance. Once you get above that, then users will start to feel their email starting to take seconds. So we want to kind of stay under that level and say in this case we're clearly under this. So in a series of workload tests in virtualized environments, we've gained a bunch of instances that's been documented in our tests. We've learned a bunch of best practices, things like, in general, the hypervisor, there was a hyper-focus on the hypervisors over the past couple of years that, VMware and Microsoft and Citrix kept saying, mine's better than yours, mine's 20% or 40% faster than yours. And what I found is all that's really gone away. The hypervisor itself is not the bottleneck. With modern processors with hypervisor assist and all the resources that are available, that's really not a concern. They're all plenty equipped for the job. Then we get into application-specific performance consideration. There are really great best practices out there. And I've got a bunch of links for you for resources if you want to learn about performance tuning for Exchange, SharePoint, or SQL Server. I've got a bunch of links here. Things like splitting cache and hub roles in in a virtualized environment, you need to make sure that you want to ensure high availability. These are kind of utility roles in an Exchange environment. You just need to make sure they're on separate physical servers. If you put two of them on one physical server, you're not HA, so there's high availability issues to consider, as well as performance issues. There's also some really great resources, Microsoft ESRP, Exchange Tested Solutions, or ETS, and also from all the vendors. So increasingly, there's great best practices to show you how you can move from a physical environment to a virtualized environment, and maybe you can do it in steps where you just virtualize some of the roles with these applications. These particular, I'm really a fan of these Exchange Tested Solutions. They're this really great blueprint that give you performance guidelines and sizing guidelines. If you want to, it kind of gives you a worksheet that you can start with a certain number of users I need to support. This is roughly the class that they are, their knowledge workers or whatever, and it will help you go through the calculations to figure out how many server cores you need, how much RAM you need, how much storage performance you need, and then they run through tests to ensure that the storage and the system deliver that level of performance, and they continue to do so in creative situations with high availability. Really great step-by-step instructions. We did similar stuff with SQL Server and an OLTP application. General low utility class SQL Server applications are good candidates for virtualization. Bigger databases like SQL Server and Oracle, as you scale up, you may still want to dedicate physical servers for them.
That's not the next order.
SharePoint's actually a good example of that, so we've got resources for these as well. In this case, in SharePoint environments, if you've got a lot of heavy web traffic that you're providing from an intranet or an extranet standpoint, that you create a CPU bottleneck. And one of the beauties of virtualization, virtual server technology, it's really easy to spin up another VM and deploy another one of these web servers. Put a little bit of load balancing under it with the software or hardware, and you can get rid of that CPU bottleneck. That's a big advantage. In the physical web, you have to keep deploying the physical web servers. Examples of Oracle testing that we did showing the advantages of subline tiering. This is for an interactive database application. Showing the difference in response times. And that's in general for multi-user applications, that's the big benefit you want to get. Use solid state, it's the idea of using just a reasonably small amount of solid state to give you a pretty big time for the performance during error recovery is something that I encourage everybody to consider. And Site Recovery Manager is technology that I mentioned before that VMware can help you automate the failover of virtual machines and remote recovery of virtual machines. And this is some testing we did to take a look at native Oracle application before and after remote wearing between data centers to ensure that we get reasonable performance. Virtualizing Oracle application, besides some performance issues, there's a support issue to consider. For a little while, Oracle's was very, very tough on supportability of Oracle applications that were virtualized with something besides Oracle's VM technology. Depends application by application as to the support that you can get for that now. VMware is standing behind, and there are plenty of people who are virtualizing Oracle applications now, but it's something you need to check besides the technology to make sure it's supportable. Spent a couple minutes on solid state performance testing. So, over the years we have a bunch of knowledge that we've learned about benchmarking and behavior of traditional disk drives. And solid state drives, they go a lot faster, right? That poses some new problems with trying to understand that performance, and they have some unique quirks that are different than storage from a performance standpoint to consider. The main problem is it's going so much faster, so understanding the performance of it, a lot of the other things that didn't get in the way now are starting to show up. Things like the size of the data or the size of the queues and block size and different application workloads can have a more dramatic difference in effect on performance than historically. And early implementations had a cliff problem with the second. So just from our demand side research, pulling 265 users recently, enterprise, medium to enterprise class organizations, 34% are reporting they're already using solid state somewhere. You can see that they're considering it, or planning. This picture here, performance dropping off, it's often called a cliff, and this is a problem with solid state. With a disk drive, generally, if you start doing a performance test on it, you'll usually fall into predictable performance within a minute or two, and you can pretty much guarantee that it will stay that way for a while, and you can come back 6 months or a year later at that level of performance. Solid state, as soon as you start to fill up the device, there's a bunch of stuff that's happening behind the scenes. NAND technology is inherently has to be erased before it's written, and there's a lot of other things that kind of wears out quicker. So behind the scenes, the performance will typically drop off. It can sometimes drop off really dramatically. And it can sometimes even vary a whole lot. So using traditional tools, that's a picture of the ionometer tool that I mentioned, a screenshot from it. If you're looking just at a moment in time, you're doing yourself a disservice. You kind of need a new set of tools to understand performance over time. If you're trying to understand how solid state. If you take nothing away from this, if you're going to do a proof of concept or try solid state, just make sure you're running your tests for a while. Run them for more than a couple minutes. Run them for hours. There's SSD Bench is an open source utility developed by one of the solid state vendors in this space, designed to help solve this problem. Command line, it'll run for hours and emulate applications and solve some of these problems. And here's some of the other tools if you want to try doing the storage performance testing yourself. Ionometer I mentioned, SSD, IOZone, FIO, JetStress is actually, here's just one. JetStress is available if you own Microsoft Exchange, you own JetStress. It's on the resource kit. It's real easy to just through a GUI to find a certain number of users that you want to test and emulate. It's a great way to burn in new hardware. It's a great way to understand the capabilities of your current storage system or plan for a new one. It's not hard to use. It takes a little while to build the database, and you need to run for a couple hours to get your good data, but it's a really good and powerful benchmarking tool. The rest of these are the links that I've mentioned during the presentation. Some results, there's some industry standard results out here as well. So SpecVert is one that I talked about. We're starting to see performance tests for solid state vendors. This last one, the benchmark gateway, is actually kind of one of my favorites there for not just for storage and performance testing. You can go and get top 10 lists on a variety of industry standard benchmarks. So thanks a lot. Thanks for bearing with me on this really, really hot day. Got just a couple minutes left. Does anybody have any questions?
In a direct attached storage environment, does performance, does it matter if it's a file server, 2 terabyte EMBK file, does that add a performance hit as opposed to straight data storage on that direct attached storage?
Does the file system, deploying it as a file system versus just block?
Yeah, a file server, a virtual file server, or standard file server. Instead of storing, your one big array, NTFS, 2 terabytes in a traditional environment, or a virtual environment where you've got 2 terabyte EMBC file with your NTFS partitioned inside that. Does that EMBK file add any performance or decrease any performance?
It's very marginal. You really shouldn't worry about it. So both file system layers, NTFS has some file system overhead. The VTUG file systems, they both have a little bit overhead versus directly something you can pass or get in or access the box. Most of the work really doesn't matter. I wouldn't worry about it. The benefits of the EMBK, you can move things around, the management far outweigh slight differences. It's going to be in the single percents if you can even measure it. How much direct attached storage behind it is really important, right? You always address MTFS or not, make sure that there's a great number of disks behind it. Just put 1, 2 terabyte drive behind that, it might not be enough to solve your performance needs.
Right, yeah, no, I really, scenario, I'm just wondering.
Anybody else? Thank you very much. Looking forward to seeing you at the lobster.